Look closely at this wall. To an untrained eye, it appears to be ordinary concrete, or perhaps ancient limestone carved into place. But what if I told you this structure contains no Portland cement, no steel reinforcement, and no industrial materials fired at extreme temperatures? What if I told you it was made from nothing more than dirt, common wood ash, and a secret liquid found in a farm kitchen? This wall behaves like natural stone. It does not rot, it does not rust, and it possesses a kind of physical memory that allows it to grow stronger with every passing year. But to understand why you have probably never heard about it, we must travel back to one of the most decisive and catastrophic moments in human history. May 28, 1453. For more than 1,000 years, Constantinople, the glittering capital of the Eastern Roman Empire, had stood virtually impregnable. Its greatest defense was the legendary Theodosian land walls. These triple-layered fortifications had shattered the armies of kings, khans, and caliphs. But on that fateful spring morning, Sultan Mehmed II unleashed the ultimate weapon of war, the basilica, a terrifying 27-foot-long bronze supercannon cast by a Hungarian engineer named Urban. For 53 agonizing days, this monstrous gun hurled enormous 1,000-pound stone balls directly into the ancient Roman walls. The shockwaves shook the ground for miles. Yet when the smoke cleared, something deeply unsettling became apparent. When those massive, supersonic stone projectiles struck the heart of the walls, they did not always break the stone apart. In many places, the impact was simply absorbed or thrown back. How could a wall built 7 centuries before the invention of gunpowder survive the most powerful artillery bombardment the world had ever witnessed? The secret was not the hardness of the outer stone. It was the extraordinary chemistry hidden within the mortar and the earthen core. When the city finally fell, not because the walls collapsed, but because one small postern gate was left unsecured, the master masons and engineers escaped westward. They carried scrolls and practical secrets that would help ignite the Renaissance. But the ultimate sovereign formula for transforming ordinary backyard soil into stone was quietly buried. Why? Because the modern cement industry, worth trillions of dollars, depends on your belief that a home cannot be built without paying for its factories, fossil fuel-burning kilns, and proprietary bags of concrete. Today, we are going to recover that buried archive. I will show you the documented path this lost knowledge followed, from the ruins of Rome to the hidden workshops of the Old Order Amish in Lancaster County. More importantly, I will give you the exact molecular recipe and the complete step-by-step process, allowing you to use it in your basement, crawl space, or backyard projects for only pennies on the dollar. Welcome back to The Root Survived. If you believe genuine knowledge of self-reliance has been pushed aside to protect corporate profits, hit the subscribe button and let us unlock the vault together. Part 1. May 28, 1453. The Last Stand of Rome. To understand why this earth and ash chemistry is so powerful, we need to examine the physics behind the Battle of 1453. Standard modern concrete is extremely rigid. Strike a modern concrete sidewalk with a sledgehammer, or expose a concrete building to powerful seismic movement, and tiny cracks begin to form. Water then seeps into those cracks, and during freeze-thaw cycles, it expands, breaks away the surface, and gradually destroys the concrete's structural integrity. But the Roman and Byzantine masons who built Constantinople understood something many modern civil engineers have forgotten. Rigidity is the enemy of durability. The Theodosian land walls were built with alternating horizontal layers of stone blocks and red clay bricks. Yet the real secret was the thick mortar placed between them. Because Byzantine engineers did not have access to the volcanic ash used by the builders of the Pantheon in Rome, they ground-fired clay bricks and broken pottery into a fine, highly reactive powder. They then mixed this pozzolanic brick dust with slaked lime and river sand. The reaction produced what materials scientists call calcium silicate hydrate, or CSH, and calcium aluminate hydrate, or CAH, the same chemical binders that give modern Portland cement its compressive strength. But because the mixture also contained coarse, porous aggregates, the finished mortar retained a slight degree of flexibility. When the basilica cannon's 1,000-pound stone balls struck the walls, this thick, elastic mortar acted like a massive structural shock absorber. Rather than allowing the wall to fracture, it absorbed the force of the impact and spread that energy throughout the entire matrix. During the chaos of the siege, local Greek citizens and Genoese mercenaries had no time to cut replacement stones. Under constant artillery fire, they desperately repaired the breaches by shoveling earth, hauling timber, and packing compacted soil into wooden forms. They discovered that earthworks absorbed the kinetic force of gunpowder weapons far more effectively than brittle ancient stone. But an even deeper secret was hidden inside this Roman concrete. It could heal itself. In a groundbreaking 2023 study, researchers at MIT analyzed samples of ancient Roman mortar. For decades, scholars had observed small white mineral fragments, known as lime-clasts, scattered throughout Roman concrete. Standard concrete manuals dismissed them as evidence of careless mixing. But the MIT team discovered that Roman builders had used a method called hot mixing, adding quicklime or calcium oxide directly to the mixture at high temperatures. This process left highly reactive, unslaked lime trapped inside the finished wall. Centuries later, whenever a microscopic crack formed and rainwater entered, that water dissolved the lime clasts. The calcium-rich liquid then moved directly into the crack, reacted with the active silica from the ash, and recrystallized into solid calcium carbonate, sealing the fracture from the inside out. The wall had been chemically engineered to function as a living, self-healing fortress. Part 2. The Whispering Wind of the Anabaptists. When Constantinople finally fell, this advanced masonry tradition did not disappear. It simply went underground. Masons and craftsmen escaped the collapsing empire, carrying their closely guarded trade secrets into Germany's Rhine Valley and the mountain valleys of Switzerland. Within these isolated European communities, the formula survived as part of a theology of self-reliance. In the early 1700s, the Swiss-German Anabaptists, later known as the Amish and Mennonites, faced severe religious persecution. They fled to the New World and settled in Pennsylvania, under William Penn's protective charter of freedom. They brought very little with them. They could not afford expensive building materials imported from Europe, and they refused to depend on the commercial monopolies of the English crown. So they turned to the resources lying directly beneath their feet. In the autumn of 1847, a Swiss Anabaptist homesteader named Jacob Baer was constructing a spring house in Switzerland's Emmental Valley, using the same traditional methods his family would soon carry to Pennsylvania. He needed a building that could withstand constant moisture, survive severe winter freeze-thaw cycles, and keep his family's milk and butter at a steady 54 degrees throughout the year, without using a single machine. Jacob did not visit a merchant to purchase cement. Instead, he went to his fireplace, shoveled out the aged wood ash from the stove, dug clay-rich soil from a creek bed 40 yards from his door, and combined them with the acidic milk whey left over from his wife's weekly cheese-making. That spring house is still standing today. Travel through Lancaster County or Holmes County, Ohio, and you can still find original Amish barns and root cellars built with this same earth and ash formula. Their walls feel like solid stone. Even on a blistering August afternoon, they remain cool to the touch and completely dry, despite containing no modern waterproofing membranes or synthetic chemical sealants. While the rest of the world entered the industrial age of bagged cement, the Amish quietly continued building as their grandfathers had, remaining completely independent of the commercial supply chain. Part 3. The Secret Ingredients. Dirt, ash, and cheese. Now let us examine the three ingredients that make this process work, and why their combination becomes so powerful at the molecular level. Subsoil clay, the structural binder. Most homeowners look across their property and notice only the topsoil, the dark, organic loam where tomatoes are planted. But using topsoil for construction is a fatal mistake. It contains large amounts of organic matter that eventually decay and rot inside the wall, leaving empty spaces that can cause structural failure. Instead, you must dig beneath the organic layer, usually 12 to 18 inches below the surface, until you reach the clay-rich subsoil. Clay is made of hydrous aluminum phyllosilicates. Under a microscope, these clay minerals resemble tiny, flat plates. When dry, natural cohesion holds them together, but they are highly hydrophilic. When water enters the soil, it pushes the plates apart and causes the earth to swell. As the soil dries, it shrinks and cracks. This is why raw, unstabilized earth structures eventually begin to dissolve in the rain. Wood ash, the alkaline activator. This is where wood ash completely changes the process. When wood burns thoroughly, it leaves behind a highly concentrated powder containing potassium carbonate, calcium oxide, and reactive silica. In effect, it becomes a pre-treated mineral compound activated by fire. Hardwood ash, especially ash produced from oak, can contain up to 89% calcium carbonate equivalent. When wood ash is added to wet clay, its alkaline compounds immediately dissolve, driving the mixture's pH above 10 and often toward a saturated level of 12.4. Inside this intensely alkaline environment, the silica and alumina within the clay minerals become highly soluble. They dissolve and react with calcium from the ash, triggering a pozzolanic reaction that forms calcium silicate hydrate, or CSH. This is the same chemical glue found in cured concrete, created entirely at room temperature from waste found in the backyard. Fermented whey, the protein cross-linker. But the true secret used by Constantinople's master masons, and later by Old Amish builders, was hidden in the liquid. According to 15th century Ottoman military manuals, masons added small quantities of animal blood to lime and ash mortars. Proteins in the blood cross-linked with the clay minerals, creating what modern materials chemists describe as a biopolymer composite. This made the finished walls literally bulletproof against the primitive matchlock firearms used during that period. In 2016, researchers at the University of Arizona confirmed the effect, showing that blood-treated earthen samples easily resisted small arms fire. The Amish did not want to use animal blood, so they discovered a much cleaner and remarkably ingenious substitute: milk whey. Whey is the liquid left behind during cheese making, and it is rich in natural milk proteins. When combined with highly alkaline wood ash, these protein chains partially unfold and react with calcium ions. This creates a structural cross-linking process that binds the clay plates together at the molecular level. Instead of producing a rigid and brittle wall, the mixture forms a dense, semi-flexible, hydrophobic, stone-like material that can expand and contract with changing weather without developing a single crack. Part 4. The chemistry of the heirloom wall, turning dirt to stone. Now let's examine the hard science behind how this material transforms from a wet mixture of mud into an heirloom-quality stone wall. This transformation takes place through two distinct chemical phases. Phase 1. Cation exchange and flocculation, the immediate set. Naturally occurring clay minerals carry a negative electrical charge and are surrounded by a double layer of water containing monovalent sodium and potassium ions. This is why wet clay behaves almost like plastic. The flat mineral plates can slide past one another with very little resistance. But when wood ash and lime are introduced, the soil becomes flooded with highly preferred divalent calcium ions, or Ca2+. Through a geological process known as cation exchange, These calcium ions forcefully replace the sodium ions attached to the surfaces of the clay particles. This immediately causes the clay's electrical double layer to shrink. The clay plates stop repelling one another. They begin to coagulate and gather into larger, loose granules through a process called flocculation. This explains why sticky, wet clay changes almost instantly when ash is added. It loses its slippery, plastic character and becomes a crumbly, damp, highly workable material. Phase 2. The pozzolanic reaction. The infinite cure. While cation exchange takes place within minutes, the second phase continues for months, years, and even decades. Because the system's pH remains saturated at approximately 12.4, silica and alumina within the clay continue to dissolve. These minerals react with free calcium hydroxide, gradually forming calcium silicate hydrate, or CSH, and calcium aluminate hydrate, or CaH, crystals throughout the open pore spaces of the soil. 2 plus SiO2 plus H2O, CSH, calcium silicate hydrate, CaOH2 plus Al2O3 plus H2O, CaH, calcium aluminate hydrate. A landmark 2019 study from Penn State Extension verified this exact chemical process. Earthen soil samples treated with a simple mixture containing 15% wood ash demonstrated an astonishing 340% increase in compressive strength after only 28 days of curing. According to a 2021 University of Granada study on lime-stabilized rammed earth, approximately 80% of the material's structural strength develops within the first 30 days. However, its logarithmic increase in strength continues indefinitely as long as free lime and ambient moisture remain within the system. You are literally growing a mountain beneath your feet. Part 5. Why modern concrete is a planned mistake. Every year, homeowners spend billions of dollars pouring concrete slabs, only to watch them crack, shift, and deteriorate within a few decades. Why does this happen? Because modern Portland cement was designed around speed, centralization, and planned obsolescence. Producing modern Portland cement requires limestone to be mined, crushed, and heated inside enormous rotary kilns at a blistering 1,450 degrees Celsius or 2,700 degrees Fahrenheit. This extreme heat triggers calcination, releasing vast quantities of carbon dioxide as an unavoidable chemical byproduct. In fact, the cement industry is responsible for an astonishing 7% to 8% of global industrial carbon dioxide emissions, more than the entire worldwide aviation industry combined. Quicklime, plus CO2, released into the atmosphere. But for the average homeowner, the real problem is the coefficient of thermal expansion. Portland cement is completely rigid. Across a 30-foot wall, a 100-degree temperature difference between winter and summer can cause the concrete to expand and contract by almost 1/3 of an inch. Because concrete possesses almost no tensile strength, this thermal movement forces microscopic cracks to form. Water enters those cracks. During winter, that water freezes, expands by 9%, and begins breaking the concrete apart from the inside. A whey-stabilized earth and ash wall behaves entirely differently. Thermal harmony. Earthen materials have a thermal expansion coefficient nearly half that of concrete. As a result, they expand and contract far less during major temperature changes. Molecular flexibility. The biopolymer protein bonds created by the whey behave like microscopic rubber bands, allowing the wall to flex and absorb minor soil movement without cracking. Breathability. The wall remains permeable. It absorbs excess moisture from the air and releases it again when conditions become dry, creating a natural and healthy indoor microclimate. Self-healing. If a microscopic crack does appear, free calcium ions react with rainwater and carbon dioxide in the atmosphere, growing new calcite crystals that heal the wall. Modern concrete struggles against the laws of nature. Earth and ash chemistry works alongside them. Part 6. The trillion-dollar silence. How the knowledge was buried. If this traditional earth and ash technology is so inexpensive, durable, and environmentally friendly, why is it not taught in architecture schools? Why can't you walk into your local home improvement store and purchase a bag of pozzolanic earthen stabilizer? The answer is simple. No one can build a multi-billion-dollar corporate monopoly around materials that are completely free. From 1780 through the early 1920s, rammed earth and earthen construction were considered mainstream building knowledge in the United States. Earthen homes were promoted as less expensive, healthier, and far superior to conventional wood framing. In 1925, the USDA even published Farmer's Bulletin No. 1500, titled Rammed Earth Walls for Buildings. It provided ordinary farmers with step-by-step instructions for constructing durable, fireproof homes from the soil directly beneath their feet. But after World War II, the industrial cement and steel lobbies grew into a massive and highly concentrated force. In 1949, the National Building Code Committee, heavily funded by these corporate interests, quietly reclassified rammed earth as a non-standard material. They did not officially ban it. Instead, they buried it inside obscure revisions to building codes. Expensive and specialized engineering approvals became mandatory for earthen homes, making it nearly impossible for an ordinary working man to obtain a building permit for one in most jurisdictions. At the same time, enormous marketing campaigns began appearing in agricultural journals. Traditional construction methods were labeled dirty, primitive, and unreliable. Young men from rural communities were drawn into general contracting trades, where they were trained to depend on bagged, pre-mixed industrial materials. Within a single generation, the continuous chain of practical folk knowledge was broken. The formulas that had kept Constantinople standing for 1,000 years were replaced by recurring monthly payments to a bank for homes constructed from materials designed to decay within 50 years. But chemistry never cared about corporate marketing budgets. Every time wood burns inside your fireplace, the raw pozzolanic binder remains in the ashes, waiting for someone to remember what it can do. Part 7. Homestead Applications. Outsmarting the contractors. Now let's talk about how you can use this knowledge on your own property today, and potentially save thousands of dollars. You do not need a building permit to reinforce, seal, or construct non-load-bearing structures on your land. Here are 4 highly practical homestead applications. 1. Sealing foundation leaks and crawl spaces. Cost: $0. Every older house eventually develops weak points. Hairline cracks in basement block walls, settling foundation corners, or leaking root cellars. I faced this exact problem in the northwest corner of my basement. Every spring, water seeped through a hairline fracture. 2 different contractors quoted me between $4,000 and $7,000 to excavate the exterior, install synthetic membranes, and pour new concrete. Instead, I dug 3 feet down along the outside of the wall, prepared a 40-pound batch of ash-stabilized clay using soil from my own yard, packed it firmly against the exterior of the crack, and allowed it to cure. That fracture has not leaked a single drop in 3 years. Total cost: $0. Total time: 1 Saturday afternoon. 2. Building beautiful, indestructible garden walls. If you want to practice this method, begin with a low garden wall or a retaining wall surrounding a vegetable bed. Because a wall under 3 feet tall is generally treated as a landscaping feature rather than a building, it requires neither permits nor professional contractors. You can create a beautiful rustic earthen wall that resembles natural stone, perfectly reflects the mineral colors of your land, and survives decades of severe winters at absolutely no cost. 3. Off-grid root cellars and storm shelters. A mixture of ash, clay, and whey is the absolute gold standard for constructing a root cellar or a storm shelter built into a hillside. Unlike modern concrete, which releases chemicals and often sweats in humid conditions. Stabilized earth naturally maintains humidity at an ideal 50% to 60%. It naturally resists rodents, prevents mold, and keeps the interior at a consistently cool temperature throughout the year, without consuming a single watt of electricity. 4. Bulletproof safe rooms and outbuildings. If you are transforming an unused closet or a basement corner into a reinforced shelter or safe room, you can pack a 4-inch layer of stabilized earth over the existing wooden frame. Once fully cured, this dense mineral wall will stop standard handgun rounds, create a complete fire barrier, and provide your home with a massive amount of thermal insulation. Part 8. The step-by-step practical recipe. Here is the exact field-tested formula passed down through generations of Anabaptist builders and optimized to provide maximum strength and water resistance. The golden volumetric proportions. To create a highly workable structural mixture that cures into a solid stone-like mass, use the following volumetric ratio: 7 parts subsoil clay, 2 parts clean coarse sand, 1 part sifted wood, ash or hydrated lime. To prepare a standard, manageable batch measuring 1 cubic foot, you will need 22 pounds of screened clay-rich subsoil, completely free of roots, organic material, and 14 pounds of dry, aged wood ash passed through a fine window screen, 3 quarts of fermented milk whey, aged for approximately 72 hours, 1 quart of clean water, added gradually and adjusted as you mix. Step 1. Preparing the minerals. Age your wood ash. Never use fresh ash taken directly from the fireplace. Fresh ash is extremely caustic and still contains unburned carbon. Place the ash in a covered barrel and allow it to age for at least 6 weeks. During that time, moisture from the air converts the raw calcium oxide into stable calcium hydroxide, preparing it for molecular bonding. Next, screen your clay. Allow the excavated clay to dry completely. Break apart any large clumps with a wooden mallet, and pass the material through a 1/4-inch mesh screen until it develops a consistent, powder-like texture. Step 2. The dry mix. Pour the screened subsoil and sifted wood ash into a wheelbarrow or mortar box. These ingredients must be thoroughly combined while they are still dry. Turn the mixture with a shovel at least 20 times, continuing until the color is completely even and no streaks remain. Any concentrated pocket of pure ash or pure clay will cure differently from the surrounding material and create a structural weak point. Step 3. Activating the binder. Slowly add the fermented whey and clean water while mixing continuously. As the liquids enter, the material will darken and gradually become plastic. Now perform the Amish drop test. Take a handful of the damp mixture and squeeze it tightly in your fist. It should hold its shape perfectly without leaving sticky mud across your palm. Then drop the ball from waist height onto a hard surface. If it smears or remains in one solid piece, the mixture is too wet. If it breaks apart into fine dust, it is too dry. But if it shatters cleanly into 3 or 4 firm pieces, the moisture level is perfect for compaction. Step 4. Compaction and ramming. Build a rigid wooden form and reinforce it with heavy clamps so the boards cannot bend outward under pressure. Pour the damp mixture into the form in separate layers, known as lifts, with each layer measuring no more than 4 to 6 inches deep. Compact every lift aggressively with a heavy wooden or steel tamper that has a flat bottom. You must reduce the original volume of each layer by exactly half. Pay close attention to the sound. When you first begin tamping, the material will produce a dull, hollow thud. But once the layer becomes fully compacted and the mineral grains lock tightly together, that sound will suddenly change into a sharp, metallic ring. That ringing sound is the signal that the clay has become stone. Step 5. The heirloom cure. Once the forms have been completely filled, wait 24 hours before removing the wooden boards. By that point, the wall will already be firm enough to support itself. However, to reach its maximum bulletproof strength, the wall must cure slowly. Cover the surface with damp burlap sheets. Protect it from direct sunlight and strong winds, and lightly mist it with water once each day during the first 2 weeks. The slower the wall cures, the denser the network of crystals forming inside it becomes. Within 90 days, the wall will be fully cured and capable of standing solid for centuries. Reclaiming your independence. At the end of the day, sifting wood ash, digging clay from your own yard, and mixing it with milk whey is about far more than simply saving money. It is about reclaiming your independence. For the past century, we have been systematically trained to believe that we are helpless without industrial corporations. We have been taught to look at the ground beneath our feet and see nothing more than useless dirt, until a company excavates it, processes it inside a factory, places a logo on a bag, and sells it back to us at a premium price. But the moment you prepare your first batch of this traditional formula, feel its heavy, cool mineral density in your hands, and hear the solid, stone-like ring of a compacted wall, that illusion of dependence disappears completely. You realize that you do not need their supply chains to construct a beautiful, indestructible, fireproof shelter for your family. You realize that the earth, the trees, and the simple elements of everyday homestead life already contain everything you need to become free. Build something that will outlive you. Build something that will remain beneath the sun as a quiet monument, showing your children and grandchildren that you refuse to forget. Tell me in the comments below, what is the first project you plan to build with this earth and ash formula on your homestead? Will it be a garden wall, a damp corner of your basement, or an off-grid root cellar? I read and respond to every single comment. And if you want to continue recovering the powerful secrets of self-reliance that modern industry tried to bury, make sure you hit the subscribe button and stay close. Because in our next video, we will unlock the legendary Amish heat sink wall, a simple, zero-cost method that keeps a homestead at a perfectly comfortable 68 degrees throughout the entire winter, without spending a single dollar on natural gas or electricity. Until next time, stay curious, stay strong, and keep your roots survived.